Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Beneath the surface of your skin, beyond the warmth of your breath and the beat of your heart, there lives a secret world, so small it vanishes beneath even the sharpest lens of the eye. It is a place made not of cities or stars, but of cells, each one a quiet universe of its own. And inside these tiny universes, nestled between mitochondria's energy hum and the nucleus's quiet thought, something new has been found, a room we never knew was there. An organelle quietly working, hidden for lifetimes beneath our gaze, whispering its function in the language of life. Imagine a house you've lived in all your life, every hallway familiar, every drawer known, and then one day you find a door you've never seen. Behind it, a room full of soft machinery, humming like a lullaby, tending to something essential. That's what scientists have just discovered. Deep inside the cells of living things, there exists a tiny chamber that no textbook ever taught. A structure so new, it doesn't yet have a name that lives in the mouths of millions, but it has a job so old, your ancestors depended on it without knowing. This organelle is not loud. It does not shout its presence with flashing light or bold color. It exists in shadows in the fine folds of a cell's inner lining like a soft breath taken in sleep. But within it, something extraordinary is happening. It manages the traffic of molecules like a librarian of life, guiding proteins and lipids to where they're needed most. In the chaos of biology, it brings gentle order. Like hands folding sheets in the quiet of morning, this organelle shapes the comfort of function, making sure each molecule finds its place. And here's the wonder, you have it too. In every cell of your body, from the tips of your fingers to the lining of your lungs, this newly discovered organelle does its quiet work. It was always there, hiding in plain sight, like the final note in a song you've heard your whole life but never noticed. Now that we know to listen, we can hear its tune in the background of every heartbeat, every blink, every thought. Scientists first glimpsed this hidden structure not in the thunder of discovery, but in the softness of curiosity. A strange ripple in the cellular sea, a blur that wouldn't sharpen. So they followed it not with force but with questions. What is this space? Why is it here? What does it do? And slowly, like the rising of the moon, the answers began to glow. It processes molecules that don't fit anywhere else. It corrects small errors before they ripple outward. It keeps peace between organelles that sometimes drift too far from their purpose. It is, in many ways, a peacemaker in the city of the cell. And this changes everything, because it means we were missing a piece of the puzzle. We thought we had mapped the territory of the cell completely, like a town with all its streets named. But this discovery reminds us, even in the smallest spaces, mystery survives. The cell is not a closed book. It is a poem still being written. Think of the mitochondria, the mighty power plants. Think of the endoplasmic reticulum, the ribosomes, the Golgi apparatus, each playing their part like instruments in a silent orchestra. And now there is another sound, a new instrument, a soft bell at the back of the stage, keeping time in ways we hadn't heard before. Some researchers believe this organelle helps explain things we never could. Why certain diseases arise in the healthiest of bodies. Why some treatments fail not because they're wrong, but because they're missing a partner. The existence of this small room opens the possibility of cures we couldn't have imagined, treatments that begin not on the skin or the blood, but inside the cell's deepest chamber. But it's more than science. It's a reminder of how little we know about ourselves. You walk every day with trillions of cells humming this secret song, unaware of the work they do. You are made of puzzles still unsolved, rooms still unopened, functions still unnamed. This organelle is not just a new chapter in biology. It is a mirror showing us the gentle complexity within. There's something soothing about that even as the world outside feels loud and sharp and fast, the world inside you is slow, soft, and constant. that in the most hidden corners of your being, new beauty waits. A structure you've never seen still cares for you. A place without name still protects you, and it always has. The scientists who found this organelle speak of it with wonder, as though describing a cave of light inside the earth. They speak of its folds and chambers, its interactions and boundaries. They use microscopes more powerful than anything from the past, tools that paint in electrons and freeze time in motion. But even with all their instruments, they cannot fully capture what this room does. It is alive in a way science is only beginning to understand. And so we dream alongside the data. Perhaps this room stores memories of the cell's past. Perhaps it listens to signals from other parts of the body. Perhaps it acts not only as manager, but as translator, helping different organelles speak the same language. We do not yet know, but the not knowing is part of the magic. The moment of discovery was not marked by fireworks. It was quiet, like dew gathering on a leaf. But in that moment, everything shifted. We now see the cell not as a completed map, but as an unfolding one. We now see life not as a puzzle solved, but as a lullaby still being written, each note soft, each word waiting. And you resting tonight carry this song in every cell. A new room, still unnamed, still mysterious, still beautiful, quietly tending to the miracle of you. Now imagine the cell again, not as a diagram from a textbook, but as a tiny glowing cottage nestled in the forest of your body. The lights inside never go out. The walls are soft with motion. The furniture is alive, shifting gently as messages pass from corner to corner. The newly discovered room, this hidden organelle, sits near the center, not demanding attention but holding space. It is not just a structure. It is a conversation, a quiet mediator between the known and the unknown. As scientists peered closer, they noticed how this organelle behaved differently depending on the cell's mood. When the cell was stressed, it glowed more. When the cell was healing, it folded itself like a blanket. It seemed to sense emotion in molecular form, not thoughts, not feelings in the way we speak of them, but whispers of change, of balance, of tension. It responded not with panic, but with poise. When something went wrong elsewhere in the cell, this room didn't shut down. It opened its arms wider. There is a name being shaped for it now in quiet labs across the world. A name made of syllables from Latin and Greek, soft-spoken among those who study life's tiniest rhythms. But before the name arrives, we can simply call it the listening room, because that is what it does. It listens. It listens to proteins tumbling into place. It listens to signals from the nucleus. It listens to the thrum of the endoplasmic reticulum, and then it moves ever so slightly to help. In our bodies, we often think of action as strength. Muscles that pull, lungs that stretch, hearts that pump. But in this cell's small sanctuary, action is different. It is subtle. It is careful. It is grace. The listening room shifts a molecule here, shields a fragile one there, pauses a reaction so the rest can catch up. Its influence is vast yet quiet, like the tide on a sleeping shore. What fascinates researchers most is how this organelle seems to remember asterisk. Not memory as in thought, but as a cellular echo. When a cell goes through hardship, say high heat or inflammation, this organelle adjusts. And when the stress is gone, it doesn't return immediately to its old ways. It pauses. It waits. It holds the imprint of what happened, and for a time it continues to behave differently, as if preparing for what might return. A gentle kind of anticipation, woven into the architecture of life. This opens a doorway into how our bodies adapt and learn on a level deeper than thought. Long before you decide how to respond to stress, your cells are already responding. Long before you heal from illness, your cells are remembering how to prevent it again. This new organelle may be part of that story, an unseen partner in resilience. It may also help explain why some people are more sensitive to change, why certain diseases appear like whispers long before they roar. If this room becomes overwhelmed, its quiet order may falter. Molecules might go astray. Proteins could misfold. Like a conductor whose rhythm is lost, the symphony may begin to slip. And when the symphony slips, the body speaks, not in words, but in aches, in exhaustion, in signals that say, something is not quite right. Yet in wellness, this room hums perfectly. Imagine a cell at peace, nutrients arriving just as they're needed, signals moving with purpose, messages clear and their paths uncluttered. This is the power of the listening room when undisturbed. It doesn't dominate the cell, it supports it, balancing its endless bustle with a softness only now understood. There's something deeply comforting in this, that at your most fundamental level, balance matters, that your body is not only made to move and act but to harmonize, that even in the smallest spaces, peace is something maintained. The newly found organelle is a reminder that health is not just strength but symmetry, not just power but poise. Think now of how many of these rooms exist in you, one in every cell, trillions of rooms, trillions of quiet interactions, trillions of choices made not by mind but by design, and all of them together create your life, your warmth, your voice, your stillness in the night. That vastness of number doesn't overwhelm, it soothes, because it means you are never alone even within yourself. There is company in your chemistry, and when you breathe, your breath reaches them, not directly but through the oxygen it carries. That oxygen moves to the blood, to the tissues, to the cells, and eventually to the listening room. And when it arrives, it is not simply absorbed, it is welcomed, guided, shared. Your very breath is part of their rhythm. Scientists are now exploring how this organelle interacts with illness. In neurodegenerative diseases, they have found signs that the listening room flickers differently. In autoimmune conditions, it may mishear its cues. And yet in many people, it adjusts again and again, resilient, faithful, forgiving. Its work is not brittle. It bends before it breaks. It tries again. It listens anew. And so do we. As we learn more about this chamber within the cell, we also begin to hear our bodies differently. The small signals, a moment of fatigue, a sudden calm, a quiet sense of imbalance begin to feel less mysterious. They become conversations between the world and the cell, between the cell and the listening room, between that room and you. In ancient times, people imagined that tiny spirits lived within the body, tending to its inner fires. That idea may sound quaint, but in some poetic sense it is true. This organelle is not magic, but it holds magic's shape, mysterious, tender, purposeful. A reminder that science and wonder are not separate, that the more we know, the more we feel. There's a beauty in discovery like this, not in the loud announcement, but in the quiet realization that something so small can change so much, that our maps were incomplete, that our inner world has layers still to explore, and that the journey inward may be just as vast as any journey to the stars. Tonight, as you rest, know this: in your deepest biology, harmony is being shaped. A new room has been found, and it was always yours. Even in stillness, it serves you. Even in silence, it listens. In your cells, a whisper moves through corridors of life, guided by a presence soft as breath. And the listening room answers, again and again, with a peace that no microscope can measure and no name can fully hold. Drift now into the quietest corner of the cell, where the listening room lives with grace and purpose. It does not sleep even when you do. It moves gently through the night, adjusting the invisible symphony of your biology. In this final stretch of the story, we return not with urgency, but with wonder. For what this tiny chamber gives you is not simply function, it is peace. It is the comfort of knowing that even your most fragile inner parts are capable of clarity, resilience, and care. As scientists learn more, they find that this organelle doesn't act alone. It speaks to the mitochondria, that furnace of energy, reminding it when to burn brighter and when to slow. It converses with the nucleus, helping shape decisions long before they reach their full form. Even the lysosomes, those breaking down bodies once thought to be mere recyclers, seem to receive guidance from this newly revealed chamber. It is, in a way, a cellular philosopher, not directing with force, but with wisdom earned through presence. More than anything, what this organelle seems to understand is timing. Every function in the body, from heartbeat to hormone, from thought to growth, relies on timing, not just speed but rhythm. And here in the listening room, that rhythm is heard before it is felt. It listens for molecular footsteps, waits for the perfect beat, then nudges life forward like a conductor's gentle baton. This is not control, this is collaboration. The idea that such elegance lives in something so small brings with it a sense of reverence. All around you, cells are changing. Some are dying, some dividing, some healing, some simply holding steady. And in each of those cells, this room is alive with purpose. If you could hear it, it might sound like a low, warm chord, always playing, never harsh. If you could see it, it might look like a lantern's glow inside a snowy field, soft and deliberate, always lit. There are signs that the listening room does more than manage. It may, researchers suggest, predict. Imagine a space inside you capable of sensing future imbalance, not far into the future, not days or months, but moments, moments that matter. The slight misfold of a protein, the rise of a calcium tide, the quiet tension of oxidative stress. It seems this organelle responds before the cell knows it needs help. It is not reaction, it is readiness. This has changed how scientists view certain conditions. In people with chronic fatigue, certain cancers, and even some mental health disorders, the listening room appears altered, not destroyed but quieter, as if the room has lost its tuning fork. This opens new pathways not just for treatment but for understanding. What if healing doesn't start with the symptom but with the whisper that comes before it? What if we could learn to speak to the list? Ending room the way it speaks to us. And what about the possibility of aging? Cells age, yes, but some age faster. Some remain youthful long after their neighbors grow tired. The presence and function of this organelle may be a clue. Its ability to prevent cellular panic, to keep the inner traffic flowing without chaos, may be part of what preserves life at the tiniest scale. Longevity, it seems, may be less about resisting death and more about maintaining harmony. The listening room doesn't fight aging, it smooths its path. It is not a warrior, it is a gardener. It trims what is overgrown, it waters what is dry, it protects new sprouts of function before they're strong enough to grow alone. In doing so, it transforms the landscape of your body without ever being seen. And isn't that the nature of true care? The hands you don't notice, the structure you never praise, quietly ensuring that everything continues to bloom. Even more astonishing is how universal this room may be. It exists not just in humans, but in animals, plants, perhaps even microbes. It may be one of life's most ancient tools, older than speech, older than memory, older than our idea of organs themselves. A thread tying us to the very beginning, when the first cell wobbled into motion on a young Earth, searching for balance in the chaos of creation. So when we marvel at how much we know, the listening room reminds us how much we don't. That beneath every discovery is another mystery, that the more clearly we see, the more gently we must look, because life is not only about what functions, but what listens, what waits, what holds. Some scientists speak of designing future medicines that speak directly to this room, molecules that don't force cells into change but invite them, therapies that knock softly on the door of the listening room and ask, "What do you need?" This would mark a new kind of medicine, not warlike but musical, not demanding but harmonizing, a future where treatment flows like poetry instead of noise. But even without those future medicines, your body already listens. Right now, as you lie still, perhaps beneath a blanket, perhaps beneath the hush of evening, the listening rooms in your cells are active. A cascade of microscopic adjustments plays on, completely unnoticed and completely yours. They do not ask for your attention, they only offer it. There's something humbling in that, something quiet and magnificent. You do not need to understand the shape of the room or pronounce its name to feel its effect. You only need to know it is there, working with you always, not in a grand, heroic way, but in a constant one, in a sacred one. In this last note of the story, let's return to the image of the cell, not a circle in a book, but a living world held together by care. Imagine it glowing softly like a candle in the dark. Inside, the listening room leans gently toward the future. It does not rush. It does not fear. It prepares. It supports. It listens. And because it listens, you go on. Perhaps the greatest meaning of this discovery is not what it will cure or what it will change, but what it teaches us to notice. The silent helpers, the gentle patterns, the truth that even in the smallest spaces there is love, there is rhythm, and there is hope. And as you sleep, the listening room stays awake, not guarding, not correcting, but caring. A quiet sanctuary in the cathedral of your biology, a secret, sacred room that you've carried all along. Beneath the veil of your skin, tucked away in every cell, lies a humming world that never sleeps. It does not roar, it does not echo, it whispers. A quiet, ceaseless murmur of molecules in motion, proteins folded like origami secrets and lipids dancing like candlelight on soft walls. This world is the factory of life, and though its machines are invisible, their music is what keeps you warm, awake, alive. You have never seen it, but you are it. Every moment you exist, it works, delicate, exact, and endlessly devoted. In this story, we travel through the endoplasmic reticulum, a name that sounds complicated but feels like home once you know it. This is the place where your cells build the tools they need, a place of slow crafting and quiet labor, a place where proteins, those folded phrases of your biology, are carefully shaped and shipped. This organelle, often shortened to ER, is like the cell's whispering factory, a system of tunnels and folds, winding through the cell like an underground stream, shaping function into form. There are two parts to the ER, one rough, one smooth. The rough ER is studded with ribosomes, tiny specks that act like letterpress printers, stamping out chains of amino acids in a rhythm older than language. They click and hum not with sound but with pattern. Each chain they create will become a protein, a key to something important, an enzyme, a hormone, a messenger, a signal. These chains are then handed into the soft, winding tunnels of the ER. Ere they are folded with care, edited like stories, trimmed like bonsai, perfected in silence. The smooth ER has no ribosomes. Its job is quieter still. It handles lipids, the soft fats that build your cell membranes, cushion your organs, and carry messages like lanterns through the blood. It also detoxifies, filtering the noise from the system, removing what does not serve, what harms, what confuses. The smooth ER is the cleaner, the chemist, the keeper of calm. While the rough ER writes the language of life, the smooth ER clears the space so that language can be heard. Together, they create balance. Like two wings of a bird, they hold the cell's potential in flight. The rough and smooth ER never speak aloud, but they respond to each other in the language of shape, charge, and flow. If one is overwhelmed, the other adjusts. If the cell is in danger, they fold faster, filter deeper. Their whispers become waltzes, coordinated in silence, dancing through the dark. And yet, even as they work, their purpose is not obvious to the eye. These are not flashy machines. There are no gears, no smoke, no signs of strain. The ER glows faintly under the microscope, like fabric stretched across the frame of life. But when you look closer, you realize that every protein in your body once passed through here. Every enzyme that digests your food, every hormone that helps you rest, every receptor that helps you feel, they were all born in this factory. They were all folded here. The ribosomes, perched on the surface of the rough ER, do not think, but they obey. They read strands of RNA, genetic blueprints unspooling like ribbons from the nucleus. Each blueprint is a recipe, a call to action, a quiet knock that says, build this. And so they do. One amino acid, then another, like beads strung in invisible hands. When the chain is finished, it is passed inside. And then the ER begins its tender magic. The folding begins. Protein folding is not random. It is an elegant collapse, a three-dimensional puzzle that must settle into just the right shape. The wrong shape leads to chaos. A misfolded protein can disrupt everything, trigger immune responses, clog pathways, or seed disease. The ER knows this. It folds with precision, checking each angle, each bond like a tailor-fitting cloth to a body. It has helpers, enzymes called chaperones, which guide the process, correct mistakes, and ease the stress. Like kind teachers, they do not scold, they adjust. But sometimes the system falters. Sometimes too many proteins arrive at once, or the folding process is disturbed by heat or toxins or inflammation. When that happens, the ER calls for help. This is known as the unfolded protein response, a soft alarm, a signal sent through the cell that says, I need time, I need rest, I need help. It is a delicate form of honesty. The cell does not collapse, it adapts, it slows down, it protects itself from further harm. In this way, the ER is not just a factory. It is a feeler, a sensor, a listener. It does not build mindlessly, it responds. It knows when to produce and when to pause. It adjusts based on what the body needs. During growth, it expands. During illness, it holds back. During stress, it balances the flood. It is, in every sense, alive with purpose. And all this happens without your knowledge. While you eat, the ER folds insulin. While you sleep, it builds receptors in your neurons. While you dream, it whispers enzymes into your bloodstream to soothe, to restore, to renew. You have never thanked it, but it has never asked. The ER is humble. Its work is in the background, behind the scenes, in the gentle hum of what keeps you whole. Now imagine this system multiplied by trillions. Every cell, every tissue, every organ, a chorus of whispering factories, each one adapting to your needs in real time, each one folding the threads of your biology into soft blankets of function. The beauty of this system is not in its speed or strength or scale. It is in its sensitivity. It listens to you, not your thoughts, but your chemistry. It hears the signals your body cannot translate into words, and it responds. Some researchers believe that understanding the ER more deeply may hold the key to unlocking treatments for diseases that have long evaded cure. Alzheimer's, Parkinson's, cystic fibrosis, conditions where protein misfolding causes the system to falter. If we can learn how to support the ER, how to ease its burden, how to speak its silent language, we may find new ways to heal. But healing begins with understanding. And understanding begins with wonder. The ER was discovered long ago, but only now do we begin to grasp its poetry. It is not just structure, it is story. A tale of folding and flow, of quiet correction and constant care. It reminds us that complexity can be gentle, that factories can whisper, that life, even at its most intricate, is born not of noise but of rhythm. And tonight, as you rest, know that this whispering factory is at work within you, not to earn your attention, but to give you peace. Its soft tunnels are shaping the very molecules that make you possible. It builds not for applause, but for balance, and in that balance you are held. You do not need to understand its chemistry to feel its care. You only need to know it's there, working for you always, folding your future one protein at a time, in silence, in patience, in grace. Let's drift deeper into the winding halls of this whispering factory, the endoplasmic reticulum, where soft labor never ends and each fold of protein carries the shape of survival. The walls of this factory do not echo. They absorb, they adapt, they cradle their work like a parent might cradle a sleeping child. In this space there is no rush, only rhythm. Molecules move as if they understand something you do not need to explain. Every task is part of a larger silence that hums with harmony. The proteins that are built here are not static, they are not final. They are stories in progress, shaped not only by code but by the conditions of the moment. If the environment is warm and calm, they fold easily like sails catching a steady wind. If the cell is under stress, folding becomes slower, more careful, more vulnerable. The endoplasmic reticulum reads these moments like a poet reading the air before reciting a verse. It does not rush into creation. It waits for the right time to shape what matters. And just as a story can shift with its telling, proteins can shift with their folding. One protein, folded one way, becomes a helper in the immune system. Folded slightly differently, it becomes a receptor in the brain. The change is subtle, like a tilt of the head, a flicker in the eyes, but that small change can determine everything: how we respond to pain, how we manage sugar, how we grow, how we heal. Folding is not just a process, it is a choice. A cellular decision made in quiet chambers, long before you feel the result. The rough ER does this work surrounded by ribosomes, those small, determined translators of genetic will. Ribosomes read RNA, which is itself a message from DNA, and turn it into long chains of amino acids. These chains tumble into the like ribbons, raw and loose. And then the ER begins: fold here, twist there, bond this loop to that corner. The structure changes layer by layer until the chain becomes a tool, a shield, a bridge, a door. The ER does not merely follow orders, it interprets them. It balances blueprint with condition, instruction with need. This is why the ER is not a simple assembly line. It is more like an art studio. It builds not just with precision, but with feeling. It senses when to speed up and when to slow down, when to produce more and when to pause. Sometimes the ER even holds proteins in waiting. It senses that they are not ready or that the cell is not ready to receive them. So it stores them gently, folding them loosely, keeping them in a state of readiness, neither complete nor discarded, simply waiting for the right signal to emerge. And while the rough ER focuses on proteins, the smooth ER takes care of other necessities. It builds lipids, not the kind that pile in the blood, but the kind that form the walls of every cell, the messengers of every signal, the lubricants of every move. Lipids are the oil that makes life smooth, and the smooth ER makes them with care. It also manages calcium, a quiet messenger that tells muscles to contract, neurons to fire, enzymes to activate. Calcium must be released carefully, like snow from a branch, or it can cause harm. The smooth ER stores it like a promise, releasing it only when the moment is exactly right. There's a whisper of protection here too. The ER helps detoxify the cell, especially in liver cells, where it neutralizes toxins and keeps the body safe from the invisible storms of food, air, and water. It does this without drama, no alarms, just soft adjustments, shifting a dangerous molecule into something harmless, folding chaos into calm. And all of this, every fold, every drop of calcium, every cleared toxin, happens beneath your notice. As you think, walk, read, or rest, the ER continues. It asks for nothing, it needs no praise. It is part of the background music of life, a score so constant and quiet that most of us never think to hear it. But if you could listen, truly listen, you might feel the beauty of it moving through you. In times of illness, the ER becomes even more important. When cells are infected or inflamed, the demand for proteins rises. The body needs more antibodies, more signals, more enzymes to respond. The ER must stretch its capacity. It must fold faster, more accurately, with fewer mistakes. If it succeeds, you begin to heal. If it fails, the cell may suffer. Too many misfolded proteins can clog the system, creating stress that ripples through the cell and sometimes through the body. This cellular stress is not unlike emotional stress. It builds. Slowly, unnoticed at first, until the system begins to wobble. The ER sends out messages, small chemical cries for help. These are picked up by other parts of the cell, triggering responses to slow production, boost repair, or if necessary, prepare for self-destruction. The cell is willing to die if it means protecting the whole. The ER does not make this choice, but it sends the signals that lead there. It is, in this way, a guardian of balance, even in death. But most of the time, the ER succeeds. It keeps the flow gentle, the folding steady, the signals soft. It maintains a balance so perfect it feels invisible. And maybe that's what real harmony is, not something you notice, but something you feel in the ease of being. The ER is the craftsman of that ease, the one who folds the corners of your chemistry into a kind of rest. There is also a growing sense among scientists that the ER speaks with other organelles, not just by physical connection, but by molecular language. It passes lipids to the Golgi apparatus. It shares signals with the mitochondria. It listens to the nucleus and shapes its response accordingly. These organelles are not isolated machines. They are more like dancers in a slow, celestial waltz. The ER may not lead, but it listens, and through that listening it guides. And so we see that the ER is not just an internal space. It is a relationship between information and form, between need and response, between silence and structure. And that relationship is inside you now. It always has been. As science continues to explore, we may discover ways to protect the ER better, to help it fold more gently under pressure, to support it when the body is tired or inflamed or ill. We may learn to treat diseases not by silencing symptoms, but by listening to the cell's own whispering factory, letting it guide us toward balance from within. But even without medicine, without technology, the ER continues its work. It folds your future every moment. It clears the noise from your chemistry. It makes sure the song of your biology is never out of tune, and it does so with grace. Tonight, as your mind drifts and your breath slows, the ER remains awake. It does not sleep because it cannot, not out of restlessness, but out of love, a cellular love, quiet and unspoken, made of shape and care and patience, a whisper that says, you are safe, you are whole, you are still being made every second by hands you'll never see, but that have always held you. Let us return once more to the folding halls of the endoplasmic reticulum, the whispering factory of life. By now you can almost feel its rhythm in your breath, in the way your body softens into rest, in the quiet way it cares for you without demand or applause. In this final stretch, we listen to what it teaches us, not only about science, but about softness, resilience, and the beauty of patient repair. Inside every cell, the endoplasmic reticulum remains steady. Even as the world outside changes, even as the body grows, falters, or heals, the ER continues its gentle folding, like the hands of a weaver who has memorized every thread. Some of its threads are short, simple proteins made for quick responses. Others are long and intricate, like enzymes that shape digestion or receptors that light up the mind. Each one begins as a string of possibilities and becomes, through the ER's patient labor, a piece of your being. There is a quiet wisdom in this. The ER does not ask questions. It does not wonder why the blueprint is what it is. It does not resist complexity. It simply responds with structure, with care, with time. It folds what is given and prepares it for the world. And maybe there is something to learn there, about how we might also meet our own complexity with less judgment and more folding. In the last years of research, scientists have found that the ER may be even more powerful than once thought. It may not only react to stress, but remember it. After inflammation has passed, after trauma has quieted, some ER networks remain altered, ready perhaps for what might return. This is not fear, it is preparation. The cell, through the ER, becomes more attuned to its surroundings, more capable of managing future waves. You could almost call it cellular memory, a form of intelligence made not of thought but of folds. In chronic illness, this memory can become a burden. The ER may stay on high alert, producing stress signals long after they're needed, like a violin string pulled too tight. But even here, it is not a failure. It is a sign that the body has learned, that it has tried to adapt even imperfectly. And through understanding this, new treatments may one day emerge, not to silence the ER, but to soothe it, to help it return to its rhythm, to let it trust peace again. Some researchers are exploring how the ER communicates with mitochondria, the energy centers of the cell. These two organelles meet at specific contact points where I pass signals, exchange materials, and coordinate responses. The ER may even help regulate how much energy the mitochondria release, like a friend placing a hand on the shoulder, reminding them to rest or to rise. It may also help control cell death, making sure it happens gently when needed without chaos or damage. This balance is sacred. Life depends on it. And it doesn't stop there. The ER also shapes the cell's shape. Its membranes stretch like branches through the cytoplasm, anchoring organelles, guiding traffic, forming pathways for molecules to move. It is not just a structure, it is a skeleton of flow. Without it, the cell collapses inward. With it, the cell breathes. In some cases, the ER even reaches out, literally sending extensions that touch neighboring cells. Through these tendrils, it may share materials or messages or help organize collective responses. It is not confined, it is connected, like a network of tiny bridges beneath the surface of your skin, allowing cells to understand each other without words. There is a metaphor here that speaks to the spirit, that sometimes our own healing depends not only on the strength of one part, but on the gentle links between all parts. That peace comes not from isolation, but from communication. That inside us, balance is built not by force, but by flow. So much of what the ER does is invisible. Its work leaves no scars, no marks, no sound, and yet its absence would be catastrophic. Without it, proteins would tangle like knots, lipids would lose their way, calcium would flood and burn, the body would unravel at the cellular level long before we'd feel the effects. The ER is the seamstress of survival, the architect of peace. And in its silence, it teaches something else. That care does not always announce itself, that the most essential work may go unseen, that there is grace in the background, always folding, always guiding, always there. It reminds us that stillness is not emptiness, it is presence practiced to perfection. Even in moments of deep illness when the body seems lost, the ER may continue its work. Not perfectly, not without error, but with devotion it tries, it folds, it corrects, it remembers, it holds hope in molecular form. And perhaps that is why some cells recover, why some systems bounce back. The ER never gives up. It does not shut down unless it must. It is loyal to life. And as we grow older, its rhythm changes. The folds become slower. The stress response is a little more frequent, but still it works. It adapts. It teaches other parts of the cell how to help. It may not be eternal, but it is enduring. Like an old song, slightly worn, still beautiful. There is a tenderness in imagining all of this. The idea that within you, there is an organelle that has spent every moment of your life folding what you need. That every healing you've ever felt began there. That every hormone, every enzyme, every quiet chemical comfort was shaped by this factory's invisible hands. And so, as this story closes, you might think of the ER not as machinery, but as a caretaker. A silent, steady presence within you, endlessly adjusting, endlessly shaping, endlessly listening. It is not famous. It does not seek light, but without it nothing works. It is the foundation beneath the foundation, the whisper beneath the breath. Tonight and every night it continues. While you drift into sleep, it folds another protein, filters another lipid, sends out another gentle signal of support. You may never meet it, never see it, never know its form, but you live because it lives, and that is enough. The whispering factory of life is not far. It is within you. It always has been. And as you rest, it carries on, folding the fabric of your being, one silent motion at a time. Every breath you take is a quiet miracle. It feels simple, air in, air out. A soft rhythm that rocks you gently from morning to night, asking for no attention, offering no sound but the hush of your own chest. But behind that simple act is a spark, a hidden flicker of life that travels farther and faster than you ever imagined. It begins in your lungs, but it does not end there. It moves through your blood, dances into your cells, and finally finds its way into the tiniest chambers of energy deep inside you. That spark is oxygen, and it carries with it not just air, but fire, controlled, sacred, and silent. This story begins in the mitochondria, often called the powerhouses of the cell. But that name, while accurate, feels too mechanical, too loud. Mitochondria are not factories, they are lanterns. Each one glows with invisible heat, fueled by the oxygen you breathe and the nutrients you eat. Their job is to turn food and air into energy, into motion, thought, warmth, and healing. They do this not with noise, but with a dance of electrons, a swirl of atoms, a chain reaction so precise it has kept life burning for billions of years. As you inhale, oxygen travels through your lungs and dissolves into your bloodstream. There it clings to red blood cells, each one shaped like a soft dish, perfect for carrying its cargo. These cells glide through your veins, carried by the slow pulse of your heart, until they reach the very ends of your being, your fingers, your eyes, your toes, your brain. And there, in the shadows of every cell, oxygen is released like a promise, a gentle knock on the mitochondrial door. Inside the mitochondria, oxygen begins its sacred task. It joins with tiny molecules of hydrogen that have been stripped of their electrons, and together they create water, a byproduct, yes, but also a blessing. In the process, the energy of the electrons is captured and stored in molecules of ATP, the currency of life. This entire process is called cellular respiration, but you don't need the name to feel its power. It is the warmth in your chest, the thought in your mind, the light in your limbs. And this spark, this transformation of air into energy, happens not once but thousands of times each second. Every breath feeds it. Every heartbeat delivers its materials. Every cell depends on it. Without oxygen, the chain stops. The spark fades, and life quietly and completely begins to dim. But oxygen does more than feed your cells. It also shapes them. It helps regulate genes, influences development, triggers healing, and balances the immune system. When a wound opens, oxygen rushes in not just to fuel repair, but to signal it. It tells cells what to do, how to move, when to multiply. It is not just fuel, it is instruction. A breath, then, is not just an act of survival. It is a message whispered into the deepest layers of who you are. There's a sacred geometry to how this works. The mitochondria are shaped like small beans or worms with two membranes, the outer one smooth, the inner one folded like waves. Those folds are called cristae, and they create surface area, allowing more space for the magic to happen. Each fold holds proteins that pass electrons, capture energy, and push protons across tiny gaps. It's a circuit made of atoms, a current made of chemistry. And oxygen is the final step, the place where electrons rest, where the charge is resolved, where the spark becomes flame. And yet you feel none of it. You do not feel the cristae. You do not feel the molecules shifting. What you feel is clarity when you breathe deeply. What you feel is calm returning. What you feel is life, soft and unspoken, moving through you like a tide. That is the mitochondria working with the air you carry. The spark of oxygen is also ancient. Long ago, Earth's atmosphere had little of it. Life began without it, simple cells that did not need air, that lived in silence beneath stone and sea. But then photosynthesis evolved. Cyanobacteria, the blue-green ancestors of plants, began to release oxygen as a gift. Over millions of years, that oxygen built up, and cells changed. Mitochondria were once free-living bacteria, but they joined larger cells in a union of shared need. The larger cell offered protection. The mitochondria offered energy, and together they made complex life possible. So when you breathe, you are participating in an agreement older than your body, an agreement between air and cell, between earth and biology, between spark and structure. Every breath is a reunion with that ancient promise, a return to the shared fire that lives in all things that move. But the mitochondria's relationship with oxygen is also delicate. Too little and energy fades. Too much and damage begins. Oxygen, though essential, can also be dangerous. It can form reactive molecules, free radicals, that bump and bruise the cell's fragile parts. This is why the mitochondria also hold their own defenses, enzymes that catch the wild oxygen, that soothe it, that guide it into useful paths. It is a balance of generosity and caution. The mitochondria do not fear oxygen, but they respect its power. And this respect teaches us something, that even what gives life can harm it if unchecked, that even the purest breath must be shaped and channeled. That balance is not the absence of danger, but the presence of care. Mitochondria teach us this without words, every moment of our lives. There is more. The spark of oxygen does not just feed the body, it feeds the brain. Your thoughts depend on it, your emotions respond to it. When you hold your breath, neurons quiet. When you breathe deeply, clarity returns. This is not imagined. The brain is the hungriest organ for oxygen, and the mitochondria within your neurons burn constantly, lighting up ideas, dreams, awareness. Even as you sleep, they glow. Even in dreams, the spark is working. And when the spark dims, during illness, during shock, during trauma, the whole body listens. Cells shift to slower pathways, less efficient, more ancient, burning sugar without air. This is called anaerobic respiration, and it is not sustainable. It is a whisper of survival, not a song of STR. The body can survive without oxygen for a time, but not thrive. Thriving requires the spark. And so we return to the breath, to the simple inhale that brings air to your lungs, to the exhale that lets go of carbon dioxide, the spent molecule, the echo of combustion. This rhythm keeps the fire alive. It keeps the spark gentle and strong. You may never feel the oxygen molecules slipping from red blood cells into your tissues. You may never see a mitochondrion lighting up with energy, but you live because of it, you think because of it, you heal because of it, and in that truth there is comfort. That something so small, so quiet, so constant, has carried you through every moment you have ever known. The next time you breathe, pause for just a moment. Let the air settle, let the spark ignite, and know that deep within you lanterns are glowing, small, sacred, and tireless. They do not ask for your awareness, they ask only for your breath, and they give you life in return. Let us drift deeper into the glow of the mitochondria, where the spark of breath becomes the warmth of being. If the first section introduced the sacred fire of oxygen, then this is where we watch it burn, quietly, endlessly within you. The mitochondria do not rest. They flicker on even when your eyes are closed, when your limbs fall still, when the night deepens and time itself seems to slow. These are the keepers of your inner flame, and though they speak no language, they understand you at the level of breath, night, and life. Each mitochondrion holds within it a story written not in words, but in enzymes and electrons. Its inner membrane folds into crystal not randomly, but with a graceful efficiency. These folds create space for a series of molecular stages known as the electron transport chain. It's a name that sounds technical, but what it truly describes is choreography. Electrons, stripped from food molecules, are passed hand to hand like sacred offerings. Each pass releases a pulse of energy. That energy is used to pump protons into a separate space within the mitochondrion, building a quiet pressure, like steam building behind a curtain. Eventually, those protons flow back across the membrane through a special channel called ATP synthase. And as they move, they turn a molecular wheel, a turbine no bigger than a ghost. That turning creates ATP, the energy coin of the cell. This is how you rise, speak, run, remember, laugh, and heal. From a breath of air and a bite of food, a tide of electrons, and the spin of a wheel made of proteins. The elegance of this process is not in its complexity, but in its balance. Nothing is wasted. Every step serves the next, and oxygen waits at the end, not as a bystander, but as the final receiver, the one who calms the charged particles and allows them to rest. But even this system is fragile. If the chain is interrupted, if the mitochondria are overwhelmed, if the oxygen is imbalanced, the spark can flicker. Free radicals may form, reactive oxygen species that strike nearby molecules, damaging membranes, proteins, even DNA. The cell, however, does not panic. It deploys antioxidants, quiet molecules that neutralize the radicals and restore order. It adjusts its rhythm. It folds its fire into a safer flame. There is a wisdom in this, not avoidance but preparation. The mitochondria know that danger is not always a storm. Sometimes it is a spark without direction. This is why when you are under chronic stress, the body feels it not only in emotion but in energy. Cortisol floods the system. Blood sugar rises, but deep within your cells, the mitochondria tighten their rhythm. They fold their cristae a little closer. They wait, they protect. They know that sustained stress dulls the spark, that too much urgency frays the current. And so they conserve. You feel this as fatigue, as fog, as a quiet slowing. But it is not weakness. It is preservation. The mitochondria also carry a fragment of history within them, their own DNA. Unlike other parts of the cell, mitochondria have their own genetic material passed down only from your mother. Every mitochondrion in your body is a descendant of hers and of her mother before her, tracing back through generations in a line of living flame. This is not just biology, it is memory. A maternal thread woven through every breath, every heartbeat, every quiet restoration. You are quite literally lit by the past. And this light is not confined to the body, it shapes the mind. Mitochondria are abundant in neurons, especially in the synapses where thoughts fire, where emotions bloom, where memory sparks. Without their energy, the brain cannot function. But they do more than power it, they help shape how it adapts. They respond to mental effort, to meditation, to trauma, to joy. They adjust their number, their shape, their function in response to your life. This is not static fuel, it is responsive light. In recent years, researchers have begun to explore how mitochondria influence mental health. In conditions like depression, anxiety, or bipolar disorder, mitochondrial dysfunction is often present. Sometimes they are fewer in number. Sometimes they produce less ATP. Sometimes their defenses against oxidative stress are weakened. This does not mean they cause emotion, but they support the systems that hold it. When the spark dims, everything feels heavier. And when the mitochondria recover, the world feels a little brighter, not just in spirit, but in chemistry. This has opened a new chapter in medicine. Treatments aimed not only at the brain, but at the cell's energy core. Diet, movement, sleep, breathwork, all of these shape mitochondrial health. And in turn, that health shapes your resilience. Your ability to think clearly, to heal from loss, to feel whole again, it is all connected. The breath, the spark, the self. Mitochondria are also involved in immunity. When cells detect a virus or a bacterial invader, the mitochondria shift their energy production. They generate signals called interferons that warn other cells of danger. They also help activate white blood cells, turning on the internal army that clears infections. But they do this without drama. Their goal is not to destroy, but to restore. Even in defense, they seek balance. They are also part of aging. Over time, mitochondria accumulate mutations in their DNA. Their efficiency declines. The spark becomes less steady. Some scientists believe that this mitochondrial drift is part of why we age, why energy fades, why tissues weaken, why memory softens. But this is not decay without purpose. It is a rhythm, a slowing that reminds us to rest, to reflect, to hold life more gently. And even as mitochondria age, the body tries to renew them, breaking down the damaged ones, growing fresh ones in their place. It is not a war against time, it is a dance with it. You can support this renewal. Sleep helps. So does movement, not punishing exercise, but gentle rhythm, walking, stretching, breath in motion. Nourishing food helps too. Antioxidants from fruits and vegetables soothe the spark. Healthy fats feed the membranes. Even stillness helps. Deep, restful moments give the mitochondria time to repair, to breathe, to glow more softly and strongly. There is perhaps no greater peace than knowing that your body is always trying to help you, even when you feel tired, even when you are ill, even when you think you are broken. The mitochondria are still there, waiting for air, folding energy, listening for the return of light. And the breath returns, it always does. The next inhale brings new oxygen, the next heartbeat sends it forth. And once again, the mitochondria receive it, light it, and carry you into the next moment of your life. This is not magic. This is biology, but it is no less beautiful. So tonight, or whenever your thoughts drift inward, remember the spark. The one you do not feel, but that feels you. The one you do not see, but that lights your every motion. Breathe in gently, let the oxygen settle, and trust that deep within you the fire continues, not in flames, but in folds, in flow, in faith. Now, as we move gently toward the end of this story, let's pause in that quiet place between breath and body, where the spark of life continues without needing to be seen. It is here, in this delicate boundary, that the mitochondria glow softly, still working, still faithful, still turning the air you breathe into the energy that holds you upright. They do not speak, but they sustain. They do not rest, but they restore. And in this final chapter, we reflect not only on their science, but on the soul of their work, the peace that arises when even the smallest parts of you are devoted to care. The mitochondria are more than machines, they are decision makers. When a cell is under threat by age, by stress, by damage, they help the cell decide what to do. Should it repair itself? Should it send a signal for help? Or should it quietly step away, allowing others to thrive? This process is called apoptosis, programmed cell death, and though it sounds cold, it is one of the most selfless acts in biology. A cell that senses it cannot serve its purpose may choose to end itself gently, without pain, without disruption. Mitochondria initiate this choice, not out of cruelty, but out of harmony. It is not destruction, it is release. It is a way of protecting the whole. Even in their endings, they show grace. There are times, of course, when this system falters. In cancer, cells often refuse to die. They block the mitochondrial signals, override the gentle exit, and multiply instead. In other conditions, mitochondria may signal too early, prompting healthy cells to vanish before their time. And yet, these are not failures of the spark. They are misfires in a system so intricate that even its errors speak of its depth. By understanding these shifts, scientists hope to develop new treatments, therapies that gently encourage the SB arc to return to balance, to restore its quiet sense of when to light and when to dim. There is hope, too, in mitochondrial transfer. In some studies, scientists have moved healthy mitochondria into damaged cells, watching as the spark returns, as function is restored. It's like lighting one candle with another. No flame is lost, but now two fires burn. One day, this may lead to new forms of medicine, new ways of healing from the inside out, cell by cell, breath by breath. But even without those future cures, your mitochondria are working for you now. Right now, in the quiet beneath your skin, they are spinning their silent turbines, producing the warmth that flows through your chest, the clarity that holds your thoughts, the rhythm that guides your breath. Each one is a pulse of possibility, and you carry trillions. There's a poetic truth in how they live. They are descendants of ancient life, but they serve the present. They hold their own DNA, but contribute to your wholeness. They live in nearly every cell, yet work without boundaries. They are singular, yet never alone. In this, they mirror something deeply human. We too are individual, yet connected. We too are shaped by the past, yet drawn forward by breath and will and light. And they do all of this within membranes so thin they are almost not there. Their crysty fold and flex with each movement of the electron chain, and yet they endure, always making space, always finding the balance between complexity and calm. They are not rigid, they are fluid, and this too is their strength. A mitochondrion may divide or merge. It may move through the cell like a traveler, seeking where it is needed most. It does not cling to location or form, it serves, it adapts. During times of healing, after injury, after illness, after sorrow, the mitochondria rise, they increase in number, they adjust their function. They supply energy where it is lacking, where pain has lingered, where repair is most needed. This is not a command, it is a listening. The cell whispers and the mitochondria respond. Their spark does not burn, it warms. It does not shout, it sings. You may wonder then what you can do for them, and the answer is simple. Breathe, move gently, sleep well, eat foods that nourish more than excite, sit in sunlight, rest in darkness. Laugh often, let go when it is time. These are not demands, they are invitations. They do not require perfection, only presence. For every act of gentle care you offer yourself, your mitochondria echo it in return. They are always waiting for that next breath, that next stretch, that next pause, and when it comes, they do not hesitate. They catch the oxygen, light the chain, and give you back your life in sparks. In some traditions, breath is sacred. In others, fire is holy. The mitochondria hold both. They are where the air you inhale becomes the light that moves you, where spirit meets structure, where life in its smallest form becomes visible only through its effects. And now, in the quiet moments when everything feels still, you can remember this. You are not idle. Your mitochondria are at work. Every thought you hold, every feeling you cradle, every heartbeat, every dream, it is all made possible by this quiet, flickering dance of air and atom and time. Even as you rest tonight, the spark continues. You may not feel it, but it is there, lighting the pathways of your brain, repairing the edges of your cells, powering the silent bloom of healing in your bones, your muscles, your breath. The mitochondria do not need your awareness. They ask only for your rhythm, and they give you everything in return. So let yourself breathe, let yourself soften, let yourself be carried. Inside you, the hidden spark glows on, warm and quiet, ancient and faithful, burning not to consume, but to create, not to destroy, but to become. And so ends this story, not with an ending, but with a continuation, because the spark never stops. It flickers on, deep in your being, alive with the breath you just took. You are lit from within, and that light, however small, however silent, is enough. Inside every cell, hidden behind the more famous structures, the mitochondria, the nucleus, the endoplasmic reticulum, there lies a framework. A structure so delicate and fine, it seems made of whispers rather than matter. It has no glow, no center, no shout. But without it, everything would collapse. This is the cytoskeleton, the cell's quiet architect. And though its name may sound rigid, what it builds is not a fortress, but a dance. What it offers is not stiffness, but flow. It is the invisible scaffolding of your life, holding you together in ways you'll never feel, but always depend upon. The cytoskeleton is not one thing, but many. It is made of 3 types of filaments: microfilaments, intermediate filaments, and microtubules. Each one plays a different role, like instruments in a slow, silent orchestra. Together, they form a web that weaves through the Entire cell anchoring organelles, guiding motion, shaping growth. This web is not fixed. It builds and breaks itself constantly. It is not a cage. It is a memory of shape, a promise of stability that adapts to every need. Begin with microfilaments, the thinnest threads. These are made of actin, a protein so ancient it exists in nearly every form of life. Actin filaments gather near the edge of the cell, creating tension, allowing movement. They are the cell's fingertips, reaching forward, feeling the world. When a cell migrates during healing or growth or defense, it is the actin filaments that push it forward, that pull it across tissues like a gentle tide. Then there are intermediate filaments. These are the anchors, the stabilizers. They don't move as quickly as actin, but they provide the cell with strength. They hold the nucleus in place. They connect pieces of the cell to each other, preventing collapse. They are made of different proteins in different cells, keratin in skin, vimentin in soft tissues, neurofilaments in the brain, each one tuned to its environment, each one holding on just tightly enough and never too much. Finally, the microtubules. These are the highways of the cell, long hollow tubes made of tubulin, a protein that assembles and disassembles like a story unfolding. Microtubules stretch from the center of the cell outward, radiating like spokes from a wheel. Along their surfaces, tiny motor proteins carry cargo, vesicles full of enzymes, mitochondria searching for oxygen, messages bound for the cell's edges. These motors walk step by step, powered by ATP, dragging their treasures with them as if across an invisible bridge. They do not hurry, they do not stumble, they carry always with purpose. All of this happens in silence. All of it happens in flow. The cytoskeleton doesn't just give the cell structure, it gives it memory. A cell remembers where it was, where it's going, and how it should respond to its surroundings, all through this inner scaffolding. It is the cell's intuition, written in threads and filaments, a map that redraws itself as needed. In development, the cytoskeleton plays an even deeper role. As an embryo grows, cells must move into position, become bone or nerve or heart. These choices depend not only on genes but on shape, and shape depends on tension, on support, on how the cytoskeleton stretches or relaxes. When the cell changes shape, it changes fate. A round cell may become skin, a long one may become a neuron. The cytoskeleton guides these changes like a soft hand shaping clay. This is true even in the brain. Neurons send out long extensions called axons, reaching across vast distances to connect with other neurons. Microtubules and actin guide this growth, forming tracks, steering turns, deciding when to branch. They don't know where they are going. They follow gradients, signals, whispers in the chemical wind. And when they arrive, they pause, build a synapse, and begin to communicate. All of this because of the cytoskeleton, because of its quiet architecture. But architecture is not just about shape, it's about change, and the cytoskeleton is always changing. When a cell senses stress, mechanical pressure, temperature shifts, chemical changes, it reshapes its cytoskeleton in response. It becomes stiffer or softer, it rounds or spreads, it pulls inward or pushes outward. These are not accidents, they are decisions, not made by thought but by tension, by balance, by the wisdom of structure. And in illness, the cytoskeleton can falter. In cancer, it may become too flexible, allowing cells to move where they should not. In neurodegenerative diseases, filaments may tangle, disrupting flow, silencing connection. In infection, some viruses hijack the cytoskeleton, riding its highways to reach the nucleus. But even in failure, we see its importance. When the scaffolding breaks, the whole story shifts, and by restoring it, we might restore health. Researchers are exploring this now. Drugs that target microtubules already exist, used in chemotherapy to stop cancer cells from dividing. Others are being developed to stabilize intermediate filaments or to encourage actin growth in healing tissues. But the goal is not control, it is partnership. The cytoskeleton is not something to be ruled, it is something to be understood, to be heard. Because it is listening, when you stretch your limbs, it responds. When you press your hand against the earth, your cells feel that pressure through their scaffolds. When you move gently, the cytoskeleton flows. When you are still, it holds. This is not passive, this is communion. So imagine now that every motion you make, every breath, every blink, every step is translated into a language your cells understand. That somewhere beneath your skin, the cytoskeleton rearranges quietly to reflect your presence in the world. That you are not just a body moving through space, but a story written in motion, shaped by tension, supported by threads of light. In this quiet architecture, there is both order and wonder. A cell may look simple under a microscope, but inside it holds a cathedral of scaffolds, constantly rebuilding itself with every signal it receives. And you, resting tonight, are built of billions of these cathedrals, each one adapting, aligning, responding. You don't need to know how actin bends, how tubulin assembles, how filaments link. You only need to know that they do. That beneath your stillness, structure is alive. That your form, your healing, your growth, your peace, all of it is shaped by this silent engineer. And it will continue to hold you every day of your life, every stretch you make, every wound that heals, every step toward becoming. The cytoskeleton does not falter, it waits, it listens, it lifts, it builds. Let's drift even deeper into the living latticework that holds the shape of you. The cytoskeleton is more than a framework, it is a language, a response, a way of knowing the world without thought. It is not rigid, it is not still. It is a tide beneath your skin, made of structure that listens and tension that speaks. The more we look, the more we realize this network of filaments is not only essential for shape, but for sense, for motion, for memory, for the delicate choreography of life inside. Begin with movement, not the grand motion of limbs, but the subtle shifts within. When a cell moves, it does not leap, it stretches. It presses against its surroundings, sensing softness or stiffness. It flows in the direction of least resistance, pulling the rear inward as the front extends outward. This motion is made possible by actin filaments, which gather beneath the membrane and push gently outward. They polymerize, forming new lengths of filament, and depolymerize behind, like waves reshaping the shore. The cytoskeleton becomes the cell's feet, its trail, its quiet courage. And what does the cell follow? Chemical gradients, gentle cues in the environment, a signal from a wound, a whisper of inflammation. The cytoskeleton turns those signals into form, into direction, into steps. Even immune cells like neutrophils, which chase after invading bacteria, do so with the help of actin. Their chase is not frantic, it is fluid. They feel their way through tissues using the quiet fingers of their scaffolding. Every moment, they are rebuilding their path. Inside the cell, microtubules stretch and grow, reaching like fingers from the center to the edge. They do not extend blindly. They search, they test, they dissolve and reform, adjusting their architecture in seconds, responding to the needs of the cell. When a signal comes in, a molecule touches the surface, a message arrives from another cell. The microtubules orient themselves to deliver cargo where it is needed. They act like roads, but also like messengers. They carry organelles, enzymes, even chromosomes during cell division. They are not just structure, they are strategy. And this is how a cell divides. It begins with a duplication of DNA, a swelling of the nucleus. Then the cytoskeleton shifts. Microtubules form a spindle, a beautiful star-like array that pulls the chromosomes apart. Each set is drawn to opposite sides of the cell, like constellations separating to make space for something new. Actin rings form at the center, tightening like a drawstring, until the cell pinches in two. What was one becomes two, not by tearing, but by folding and guiding and releasing. The cytoskeleton choreographs this division with a grace so perfect. It happens billions of times each day, unnoticed. Even neurons, the most delicate, most extended cells of all, rely on the cytoskeleton to send their messages. Along their axons, microtubules line up like rails, guiding neurotransmitters from the center of the neuron to the synapse at its tip. The motor proteins that walk these rails do so step by step, carrying vesicles full of thought. And if the cytoskeleton weakens or tangles, as in Alzheimer's disease, those thoughts slow, signals fade, connections wither. Not because the mind is lost, but because the scaffolding has forgotten how to carry. But there is hope. The cell is not helpless. When the cytoskeleton is injured, it rebuilds, it pauses. It sends repair proteins to the site. It reshapes what has fallen. This is how wounds close. This is how skin renews. This is how you recover from the smallest bruises to the deepest breaks. The cytoskeleton does not forget. It returns again and again to its task of holding, of lifting, of guiding you back into form. It also listens to the outside world. Cells in your body sit within an environment called the extracellular matrix, a soft weave of proteins and sugars that surrounds them like a cradle. The cytoskeleton is tethered to this matrix. When you stretch a muscle, the matrix stretches. The cytoskeleton pulls inward in response. When you press your hand against the ground, your cells feel it, not through the ski and alone, but through the push and pull of these internal threads. They respond by growing stronger or softer or stiffer, depending on what the environment teaches them. This is mechanotransduction, a long word that simply means the language of touch, written intention. Even in your bones, the cytoskeleton plays a role. Osteocytes, the cells that sense pressure within bone, stretch their filaments out through canals, touching other osteocytes across distance. When you walk or run, they feel the compression. When you rest, they feel the release. And they signal to remodel bone accordingly, to build where stress has passed, to dissolve where quiet has returned. This is why your skeleton is never static. It is always learning, and the cytoskeleton is its instrument. And what of the heart? Cardiomyocytes, the cells of your heart muscle, contract with each beat because of finely tuned filaments, actin and myosin sliding past one another, synchronized in pulses that ripple from cell to cell. These fibers are anchored into the cytoskeleton. When the rhythm falters, the filaments try to restore it. When the beat stutters, they adjust. When injury comes, they resist. The cytoskeleton is not just a scaffold, it is the rhythm keeper of the heart. What's most humbling is that you do not feel this directly. You feel strength, yes, or weakness, but the building of your body happens silently. While you speak, your cells are rebuilding tension. While you sleep, they are reshaping their filaments. While you heal, they are weaving new support, thread by invisible thread. And it is not only physical. Even the immune system relies on this structure. When a white blood cell engulfs a bacterium, it wraps its membrane around it like a soft glove. That glove is shaped by actin. The cytoskeleton reaches forward, traps the invader, folds it inward, and then retreats. This is not violence. It is precision, defense made gentle. What happens when this balance breaks? In autoimmune disease, cells may misinterpret signals. The cytoskeleton may overreact, creating too much tension, sending too many messages, guiding cells into attack when rest was needed. In this, we see the need for balance, not only of structure, but of signal, of patience. The cytoskeleton is a mirror, and when the world around it is rushed or strained, it reflects that stress in form. And yet it always tries to return. This is the wonder of it. The cell can bend, it can wobble, it can even break. But its cytoskeleton begins again, gathering proteins, shaping filaments, restoring architecture. There is a softness to this resilience, a wisdom born not of certainty, but of constant response. You are not aware of this work, but you are made from it. Every gesture, every posture, every breath is shaped by these internal beams. You sit because your cells stand. You move because your cells shift. You heal because your cells remember the shape they once held and try to hold it again. So when you lie down tonight and the world quiets around you, know that your cells do not sleep. Not completely. Their scaffolds loosen, yes. Their tension lowers. But they continue to hold you gently, adjusting your form, responding to gravity, to temperature, to rest. They do not need light. They do not need thanks. They only need time, and they give you shape in return. You are held together by softness, by tension, by flow, and in that invisible architecture there is something beautiful, not just that you are made to stand or walk or mend, but that your very structure listens, to pressure, to stillness, to the world around you and the world within. The cytoskeleton is your first architecture, your last architecture, your constant, gentle frame, and it will continue to hold you long after you've stopped thinking about it. Like a breath, like a rhythm, like a thread spun from the center of your being and woven outward toward light. Now let us return one final time to the lattice that holds you, the cytoskeleton, The cell's quiet architect has no voice, yet it has always spoken. Its message is written in threads, in movement, in grace. It is not fixed like the beams of a building, nor fragile like spun glass. It is a living framework, one that bends with your emotions, adapts to your surroundings, and renews itself with the passing of time. It is the breath within your bones, the invisible design beneath your gestures, the pattern that lets you be not only stable, but alive. This framework does not live alone. In every cell it collaborates with the life around it. The nucleus, with its coils of genetic memory, sends out instructions. The cytoskeleton receives them not as rigid orders but as suggestions shaped by context. If a cell must grow, the filaments shift. If a cell must divide, they reweave into symmetry. If a signal arrives, chemical, mechanical, or electrical, the scaffold does not resist. It responds, it listens. It stretches and shapes itself to allow the next form to take root. But the most remarkable thing about the cytoskeleton is not what it holds, it is what it allows, because structure alone is not life. It is the flexibility within the structure that creates potential. The cytoskeleton is a master of this paradox. It holds just tightly enough to give the cell its shape, and yet loosely enough to allow change. You are not made of walls, you are made of bridges, and bridges can carry dreams. In neurons, for instance, the cytoskeleton is constantly in flux. When you learn something new, an idea, a melody, a name, the architecture of your brain shifts microscopically. Dendrites branch further, synapses strengthen, connections form. These changes are physical, sculpted by microtubules and actin filaments that extend into the growing tip of a nerve cell. Your very thoughts leave trails in the scaffold. Each memory is a fold, a reach, a soft rearrangement of internal space. Learning is not only mental, it is structural, and the cytoskeleton remembers. In the immune system, the cytoskeleton guides how cells patrol, how they recognize danger, how they cling to invaders or present antigens to others. Its fibers stretch and constrict, forming pockets to carry information, creating structures to present identity. The response of the immune cell is only as accurate as its architecture allows, and in healing, the cytoskeleton leads the way. Wounds close not only because of clotting and regeneration, but because the cells around the damage stretch toward it. They lean in, touch, and bridge the gap with scaffold and motion. Healing is a reaching. Healing is a reshaping. Even the most stable structures in the body, bones, cartilage, skin, are alive because of this framework. Osteoblasts and chondrocytes, the builders of bone and cartilage, rely on internal scaffolds to orient their work. Skin cells align with tension. When you smile, your muscles pull and your skin stretches. The cytoskeleton absorbs this pattern and remembers it. In this way, even your expressions are reflected in the way your cells hold themselves. You are built from gestures. And when life changes, when grief strikes, or joy expands, or silence deepens, the body feels it, not just in chemistry, but in structure. Studies suggest that stress changes the way cells shape themselves. Tension alters the architecture. Cortisol, the stress hormone, flows into cells and can soften the cytoskeleton or make it rigid. The world touches you and your cells reflect it back, not symbolically but literally. Your biology reshapes in response to your living. But this also means that rest can rebuild you. That gentle breathing, stillness, safety, kindness, these things help the cytoskeleton loosen and return to its natural rhythm. Stretching the body, moving with care, letting go of unnecessary force, these are not luxuries. They are scaffolding rituals. They invite the filaments inside you to return to grace. And they do. The cytoskeleton never gives up. It breaks and reforms. It collapses and rebuilds. It tears and it returns. Its proteins are constantly recycled, its filaments disassembled and repurposed. There is no waste, only change. Even in aging, the cytoskeleton adapts. It becomes slower, perhaps, a little more hesitant, but it still tries, it still holds. It still gives the cell the dignity of form. Scientists now study the cytoskeleton not only for its mechanics, but for its role in communication. It transmits forces, it carries messages, it even helps determine which genes are expressed. Depending on the tension in the cell, different parts of the DNA may become more or less active. Shape influences story, structure influences expression. You are not just written in code, you are written in form. In some future, medicine may learn to speak directly to the cytoskeleton, to reinforce its balance during injury, to soften it in stiffness, to guide it in regrowth, but already your body knows how. Every cell contains this knowledge. Every breath carries the energy to fold and stretch these filaments into what you need next. You don't have to understand how it works to benefit from it. You are its result. And now, as this story nears its end, return to the image of the cell, not as a dot beneath a microscope, but as a room filled with beams of light weaving in every direction. At the center, the nucleus glows. Around it, mitochondria pulse. Vesicles move like stars. And through it all, the cytoskeleton stretches and curves, holding not only the contents of the cell, but its purpose, its response, its grace. This scaffold is not cold. It is not hard. It is woven from the same softness that lets skin heal, that lets the heart beat in time, that lets the fingertips trace the curve of a thought. It is perhaps the most gentle architecture in the universe, and it lives in you. So tonight, as you sleep, your body does not fall still. Your cells shift, the scaffolds realign, the filaments let go of tension and find a new shape. They hold you through the night without your knowing, and when you wake, they rise with you, silent, strong, endlessly forgiving. You are built by threads that do not break, only bend. You are shaped by forces that are not loud but lasting, and in your quietest moments, you can almost feel it. That silent architecture within, gently holding you together and quietly always helping you begin again. Within the walls of every living cell, there is a guide, a patient map maker who never sleeps. This map maker doesn't draw with ink or compass, but with molecules and motion. It works quietly, tirelessly, organizing where things must go, what must be built, what must be sent, and what must be returned. It knows the geography of the cell not from observation, but from memory passed down through the ages of life. This mapmaker is the Golgi apparatus, and though it hides in the shadows of more famous organelles, its role is no less vital. It is the postal service, the architect, the route planner, the label writer, and the customs agent, all in one. And through it, your cells remain connected, shaped, and purposeful. The Golgi is not a single structure, but a stack of folded membranes, each layer curved like ribbons caught in wind. It sits often near the endoplasmic reticulum, collecting the packages sent from that whispering factory. These packages are proteins and lipids, freshly built, not yet finalized. The Golgi takes them in with quiet care and begins its sacred work: modification, sorting, and delivery. Each layer of the Golgi serves a purpose. In one, a sugar might be added to a protein. In another, a tag might be attached, signaling where the molecule should go. These modifications aren't decoration, they are direction. A protein without the right sugar may drift aimlessly, but one touched by the Golgi carries its address like a note in its pocket. This is glycosylation, the act of placing sugars on proteins like soft stickers of identity. Through this, the Golgi tells the protein who it is, and more importantly, where it belongs. This map maker is precise. It does not guess, it does not hurry. It studies each molecule that passes through its folds. Some it sends to the membrane where they will become part of your outer form, receptors, channels, gates. Others it ships to lysosomes where they will help break down what no longer serves. Some it sends out of the cell entirely into the blood, the lymph, the space between tissues, messengers of instruction, hormones of intention, enzymes of action. Nothing is wasted. Nothing is misplaced, or at least not when the Golgi is well. And yet the Golgi does all of this silently. No pulse, no flash, no roar of production. It is a system of trust. The proteins enter, the modifications occur, and they are sent onward like birds in flight. You will never feel it, you will never see it. But the proteins that form your skin, the ones that digest your food, the ones that regulate your heartbeat, all of them pass through this organelle. All of them were marked by the hand of the map maker within. There is beauty in its stillness. The Golgi doesn't generate energy like mitochondria or read genetic blueprints like the nucleus. Its power is in order, in navigation, in knowing where things belong and making sure they arrive. It is the postmaster of the cell, yes, but also the composer, arranging the instruments so that the music of life can play on. And this is not simple work. Each protein, each lipid is a question. Where should it go? What should it become? What shape does it need to take to do its work without harm? The Golgi answers not with thought but with chemistry. It reads the structure. It feels the charge. It senses the journey ahead. Then it folds, edits, attaches, and releases. And always it learns. The Golgi can change its rhythm depending on the needs of the cell. In stress, it may increase its processing speed. In growth, it may expand. In certain diseases, it may fragment, its stacks dispersing like pages torn from a book. But even then it tries, it regathers, it reforms. The mapmaker is not rigid, it is resilient. Consider the role it plays in the immune system. Antibodies, those intricate proteins that defend you, must be perfectly shaped. The Golgi adds the final touches. Without these, the antibodies might fold incorrectly or drift to the wrong places. The Golgi is the final editor before publication, and because of this, its silence is vital. Inaccuracy here doesn't mean noise, it means confusion. And confusion in a body built on harmony can ripple outward. Even in the brain, the Golgi plays its part. Neurons are long, stretched cells with complex needs. Their receptors, neurotransmitter proteins, and synaptic machinery are all touched by the Golgi before reaching their destination. This ensures that each signal you send, every thought, every dream, every flicker of memory, is carried out with precision. And what of development in the earliest days of L? Ife cells must become organs, tissues must form layers, shapes must emerge. The Golgi helps orchestrate this. It sends proteins that create adhesion between cells. It places enzymes in the right pockets of space. It determines the location of receptors that read the environment and respond. Without it, the blueprint of life would remain unreadable. The Golgi writes the margins, underlines the meaning, adds punctuation to the sentences of the genome. You may never think of it, you may never hear its name again, but you live because it does its work. And there's something comforting in that inside of you there is an organelle that quietly ensures that things get where they are meant to go, that messages are not just made but delivered, that purpose once shaped finds its destination. This is not just biology, it is poetry, a reminder that life is not only about what is created, but about what is cared for, finished, sent. The Golgi is that caring, that finishing, that sending. Tonight, as you rest, your cells continue this work. Proteins folded in the endoplasmic reticulum move gently toward the Golgi. The mapmaker inspects them, modifies them, labels them. And then, as if placing a letter in a postbox, it lets them go. They travel silently toward the places they are needed. And in their travel, your body continues to function, to feel, to heal. You are not aware of it, but it is aware of you. In every heartbeat, in every breath, in every glance toward light, there are molecules shaped by the Golgi, carried across distance, delivered on time, holding form because the mapmaker within knew where they belonged. And that knowledge, the quiet precision of cellular purpose, is part of what holds you together. So rest now. Somewhere inside you, ribbons are folding, proteins are being labeled, destinations are being chosen. And though you may never feel it, you are being guided in ways deeper than you know by a structure that asks only to help you become whole. Let's return to the folds of the Golgi apparatus, the cell's quiet mapmaker, and travel a little deeper into its corridors. It does not change the world by volume or force, but by placement, by direction, by soft decisions made moment to moment. It does not create the ingredients, but it ensures the recipe is followed. It finishes what was started. It blesses each molecule with identity and purpose. In the orchestra of the cell, it is not the composer nor the instrument, but the conductor, raising no baton yet guiding everything forward in harmony. Each molecule that passes through the Golgi does so like a traveler in transit. A protein arrives from the endoplasmic reticulum, new and full of potential but unfinished. In the first cisternae, those curved membranes stacked like lily pads, enzymes begin to inspect it. Is it folded properly? Has it been tagged with the right sugars? Does it carry the signals that say, send me to the membrane, or deliver me outside, or keep me within? Each layer of the Golgi is like a stage of refinement. Not rushed, not delayed, just the right touch in the right moment at the right depth. Imagine now a protein destined to become a hormone, perhaps insulin. After its folding and editing, it is wrapped in a vesicle, like a parcel, soft and round, made from the same material as the membrane that will one day receive it. The Golgi packages it with intention, enclosing it in a tiny bubble, and then labels the outside with markers made of sugar or lipid, codes that other organelles will understand. It is released then into the cytoplasm, where it will travel to the cell's edge, fuse with the membrane, and spill its message into the bloodstream. From a cell in the pancreas to the furthest edge of the body, this hormone will guide sugar into balance, and none of it would be possible without the Golgi. This journey repeats endlessly. Enzymes for digestion, receptors for communication, antibodies for protection, even mucus to line your lungs. Each of these passes through the Golgi, receiving modifications so subtle, so intricate, they are like the brushstrokes on a master painting. And when these modifications are absent, the consequences echo. Some rare genetic diseases involve enzymes that fail to function in the Golgi. Without those changes, proteins get lost. They arrive in the wrong places or miss their function entirely. The map was written but unreadable. The letters were sealed but not addressed. And so we see, it is not enough to make something. It must be refined, it must be known, it must be sent. The Golgi doesn't build identity, but it affirms it. Within the cell, the Golgi also supports communication. It helps produce the lipids and receptors that allow the cell to speak to others, tiny ligands and binding partners that form the handshake between neighbors. In your nervous system, neurotransmitters are prepared, packaged, and guided with the help of this structure. Without it, even the signals of thought would drift unformed. The Golgi apparatus can also expand or shrink depending on the needs of the cell. In immune cells during inflammation, the Golgi grows busier. It produces cytokines, small protein messengers that call other cells to action. When the immune response ends, the Golgi gently quiets again, shrinking into its resting folds. It is a dynamic structure, not fixed, but living, moving, changing shape like a living letter writer adjusting to the tone of the message. This organelle even adapts during development. In embryos, when cells are deciding their identity, whether to become skin, muscle, or blood, the Golgi contributes by ensuring that the right surface proteins are sent to the right places. These surface proteins help cells stick together, recognize one another, communicate, and form tissues. The Golgi writes the tags that let cells say, I am liver or I am lung. Without this identity, the embryo cannot organize. Without this map maker, the blueprint remains unread. Scientists are now uncovering new layers to its role. The Golgi seems to communicate with the cytoskeleton, the scaffold that holds the cell's shape. It may even influence how that shape is maintained or how cargo is moved along microtubules. In some cases, the Golgi aligns itself according to the cell's polarity, helping to guide vesicles toward the leading edge during migration. A stationary structure with a directional sense, like a compass built into a post office, guiding letters and packages not just outward, but precisely forward. And in times of cellular stress, when the endoplasmic reticulum overflows or mitochondria send out distress signals, the Golgi may fragment, its stacks breaking apart to prevent collapse. But this fragmentation is not destruction. It is an act of triage, a temporary reshuffling to protect the cell. And when balance is restored, the Golgi reforms, reassembles, returns to its center. It is not immune to chaos, but it knows how to recover. There is a metaphor here, quietly waiting beneath the biology. That organization is not about rigidity, it is about resilience. That guidance is not about controlling everything, it's about knowing when to adjust. The Golgi is the master of this. It does not stop working when overwhelmed, it works differently, it finds another path. Even in neurons, whose long extensions stretch like rivers through the nervous system, mini Golgi outposts can be found near the dendrites. These smaller stations perform their own sorting and tagging, ensuring that synapses, the points where signals are passed, receive the exact proteins they need. The brain does not rely on a central station. It builds satellite map makers wherever direction is required. Adaptability written into structure, intelligence embedded in architecture. This reveals a truth as old as life. That function depends on placement. A single protein can become medicine or confusion depending on where it lands. A message is only useful if it arrives at the right time in the right place, and the Golgi ensures this. It is not the speaker. It is the messenger's hand, the unseen part that makes understanding possible. So much of what your body does relies on this map maker, but it never asks for your attention. It never falters for applause. It folds and tags and sends again and again without recognition. And because of this, you live with balance, you heal with clarity, you wake with structure already in place. Perhaps this is why the Golgi was discovered relatively late in scientific history. It is quiet, tucked into the shadows of the cell, its work complete before it is noticed. But its presence is everywhere, in your skin, in your blood, in your breath. In every molecule shaped not just by what it is, but by where it is going. The cell is a city, and the Golgi is its postmaster, its traffic guide, its whispering map maker. And as long as it folds its membranes and tags its cargo, your story continues, not in bursts but in streams, not in noise but in direction. Tonight, as your breath slows and your body leans into rest, the Golgi folds on. A protein finishes its journey. A vesicle begins to bloom. A sugar is gently added to a molecular edge. And with that, the cell's message is made clear. And life quietly, gracefully is delivered. Somewhere within you right now, a package is being prepared. It does not bear your name, but it is meant for you. A protein, freshly folded, awaits the final marks that will tell it where to go, what to do, and who to become. It moves gently through curved corridors, wrapped in a bubble of membrane. This package is not a metaphor, it is real. It is part of how your body heals, thinks, remembers, grows. And it is being shaped in this moment by the Golgi apparatus, the map maker within. In this final passage of our story, let us rest in the deep understanding of what the Golgi truly does, not only for your cells, but for your being. It is easy to overlook it, hidden as it is among the more well-known organelles. But what would you be without direction, without completion, without the quiet touch that takes a raw molecule and whispers to it, "Here is your place, here is your task, go"? That touch is the Golgi. Proteins are not born ready, they are crafted. They emerge from the endoplasmic reticulum like fledgling birds, shaped but not yet ready to fly. The Golgi is the nurturing tree branch. It inspects each wing, trims each feather, attaches a tag, and releases the bird to the air with knowledge of direction. Some will fly to the cell's membrane and rest there as gates or signals. Some will soar out into the bloodstream to guide distant tissues. Some will nest deep within the cell to maintain balance, break down waste, or join in building new structures. Each flight began with a message from the map maker. And what a message it is, one of precision, care, and profound timing. A hormone released too early or too late is ineffective. An enzyme misplaced can become destructive. A protein intended for the outside may cause harm if kept within. The Golgi ensures that each arrives at its destination just when it is needed and nowhere else. It is not simply about movement, it is about meaning, it is about trust. In the intricate dance of healing, for instance, the Golgi plays a central role. When skin is wounded, cells near the injury send out cytokines and growth factors, molecules that direct repair. These must be perfectly formed and delivered. The Golgi prepares them all. It tags them, packages them, and guides them to the surface of the cell, where they are released into the extracellular space like notes on a breeze. Other cells catch these notes and respond, migrating, dividing, building. The entire orchestra of healing plays because the Golgi set the tempo. Even in the processes of aging, the Golgi leaves its trace. As cells grow older, their ability to manage protein traffic can falter. The mapmaker becomes weary. Packages may be misrouted, delayed, or lost. Scientists believe this breakdown contributes to many age-related diseases, neurodegeneration, metabolic disorders, immune dysfunction. But the very fact that the Golgi's health is linked to aging tells us how central it is to life's harmony. When it functions well, youth is preserved, not in appearance, but in clarity, in precision, in the reliable flow of the internal world. And still, the Golgi does not cry out for attention. It continues, quietly reshaping proteins, guiding lipids, building glycoproteins, forming vesicles, all without thought, all without noise. It is as if your body knew from the very start that some of the most important work must be done in silence. The Golgi is also a place of surprising flexibility. In certain cells, it can expand like an accordion to handle more traffic. In secretory cells, those that release hormones, mucus, or digestive enzymes, the Golgi is more developed, more folded, more expressive. It grows to meet the need. It adjusts to the rhythm of the cell's task. It does not demand control. It responds to the moment. And in doing so, it embodies a lesson we often forget. To be useful is not always to be visible. Even its shape, the soft stack of cisternae, is meaningful. These folds create space for stages. Each fold carries a different set of enzymes, a different piece of the journey. There is a beginning, a middle, and end, like a gentle assembly line with no harsh edges, no abrupt motions. The molecules move from one side to the other in small, lipid-wrapped vesicles. The journey is not rushed, but inevitable. No molecule lingers longer than it must. No pathway is taken without guidance. And so the Golgi becomes something more than an organelle. It is a keeper of rhythm, a guardian of timing, a steward of precision. Without it, the cell would be flooded with potential, but lost in purpose. The difference between chaos and harmony lies in those sugar tags, those final touches, those delicate releases into vesicles. What does this mean for you, the one who carries this map maker in every cell? It means you are built on trust, on timing, on coordination that never calls for applause. It means your health, your thought, your very breath depend not only on big moments, but on countless small completions, each made possible by the Golgi. In modern science, this organelle is being studied with increasing wonder. Researchers are learning how its dysfunction may contribute to Alzheimer's disease, how viruses hijack its vesicles, how cancer cells reshape it for their own gain. But they are also discovering how its resilience might be harnessed, how to restore its structure in aging, how to enhance its traffic in healing, how to correct its sorting in disease. There is hope in this research, and behind it awe. Because even now, we are only beginning to understand how much this quiet worker holds together. So take a breath, feel the weight of your body resting, let your mind soften. In the background, invisible to you, the Golgi continues its work. A protein folds, a sugar attaches, a vesicle blossoms, a molecule is sent on its way, and though you feel nothing, everything depends on this. The mapmaker is not concerned with recognition. It will not stop to ask if you're watching. It will not falter if ignored. Its commitment is to order, to clarity, to flow. Every minute of your life, it organizes what is needed and lets it go. And so you are free to be, to think, to heal, to feel joy, to grow old, to dream. Because somewhere inside you, folded like a ribbon between the hum of other structures, there lives a quiet guide, a Golgi apparatus, that sees every possibility and answers softly with direction. Beneath the still surface of every living cell, there is a quiet conversation always underway. You cannot hear it, but it is there. A dance of messages passed in whispers like water dripping softly onto stone. The organelles inside your cells, each with its role, each with its rhythm, do not work alone. They speak to one another, not in words, but in molecules, in motion, in gentle proximity. And through this hushed symphony of exchange, life becomes more than a sum of its parts. It becomes a conversation, flowing gently between those who remember, those who build, those who fuel, and those who guide. The nucleus, sitting calmly at the center like a lantern of memory, does not simply command. It listens. Wrapped in a double membrane, it protects the cell's most delicate truth, its DNA, but it also responds. When the environment changes, when stress approaches, when signals arrive from outside, the nucleus reads them like letters from the world. Then, through its pores, those round windows lined with delicate guards, it sends out instructions. These are strands of RNA, messages made of coded whispers, destined for the cytoplasm. But the nucleus doesn't send them into silence. It knows they will be received. Near its outer edge, like a folded cloth still warm from touch, the endoplasmic reticulum waits. It is not idle, it is ready. As the RNA strands drift near, they are embraced by the ribosomes, tiny readers perched along the rough surface. These ribosomes are like weavers at a loom. They read the RNA and stitch together proteins, bead by bead, in perfect order. This act is not mechanical, it is sacred. Each amino acid added is a decision made with care, a conversation remembered. A response formed in structure. But the endoplasmic reticulum cannot finish alone. It speaks to the Golgi apparatus through delicate vesicles, round and soft, carrying newly made proteins like thoughts in transit. These vesicles bud from the and drift toward the Golgi, fusing with its curved membranes. No words are needed. The Golgi knows what to do. It modifies, packages, and directs each protein as if continuing a sentence the began. This is not assembly. It is dialogue. The Golgi answers what the started. And in doing so, it brings the protein to its purpose. Then there is the mitochondrion, the energy bearer. Often called the powerhouse of the cell, it is so much more than that. It senses the cell's hunger, the rhythm of its work, and adjusts accordingly. It speaks through molecules like ATP, energy coins passed quietly to fuel every process, but it also listens. When calcium levels change, when oxygen dwindles, when signals of danger rise, the mitochondria feel it. They change shape. They send messages back. Sometimes these messages are small adjustments. Other times they are calls for help. And the hears them. These two organelles, the and mitochondria, share a special bond. They touch each other directly at regions called MAMs, or mitochondria-associated membranes. Here lipids are exchanged. Calcium flows from one to the other in tiny pulses. Signals about cell health, about division, about death are passed through these quiet channels. If the cell is calm, the exchange is soft, steady. If the cell is stressed, the dialogue intensifies. And when the decision must be made, whether a cell should heal or gently end its life, it is often here, between these two, that the conversation concludes. But they are not the only ones talking. The lysosomes, those tiny recyclers, listen too. They receive old proteins, broken organelles, unwanted material, and dissolve them with care. Yet even they speak. They send signals to the nucleus, telling it when recycling is complete or when the cell is becoming burdened with waste. If their load grows too heavy, they request more enzymes. If something cannot be digested, they alert the larger network. Even destruction has a voice. Even the end of something is part of the cell's ongoing story. Peroxisomes, those small guardians of detoxification, send signals when they encounter certain lipids or toxins. They break things down with enzymes, yes, but also share molecules with the mitochondria and Their message is this: here is what we encountered. Her. Is what must change. Here is what must be built differently next time. And the cell, through its organelles, remembers. In this way, the cell is not just a factory. It is a circle of friends, a family of structures bound by trust. Each knows its part, each adjusts to the others. None stand above, none stand alone. If the Golgi is overwhelmed, the slows down. If the mitochondria struggle, the whole cell shifts its pace. If the lysosomes are full, the cell reconsiders what it sends them. This is not just function, it is compassion written in biology. Even the cytoskeleton, the cell's internal scaffolding, contributes to the conversation. Microtubules and actin filaments guide vesicles like rails in a gentle subway, helping messages get where they must go. They do not speak, but they listen deeply. They respond to the tension in the cell, to the flow of calcium, to the position of the Golgi and the mitochondria. They realign, reshape, rebuild. They carry the physical form of the dialogue, giving it direction and grace. And around all of this is the plasma membrane, the cell's outer shell. But it is not a wall. It is a sensitive listener. It receives signals from the world, light, touch, nutrients, molecules of emotion. It sends these inward in ways the organelles can understand, sometimes through proteins that change shape, sometimes through chemicals that ripple inward like a soft alarm. And when the outside world shifts, the inner world shifts too. The more science learns, the clearer this becomes. Life inside the cell is not isolated, it is interconnected. Organelles send signals to one another. They adjust based on feedback. They pause when needed, push forward when possible. The health of the cell is not about the strength of any one part, but the balance between them all. And what about when this conversation breaks down? That too teaches us. In diseases like Parkinson's or ALS, the ER may misfold proteins. The Golgi may become fragmented. The lysosomes may fail to digest what they receive. The mitochondria may send out distress signals too late. It is not one flaw, it is a breakdown in communication, a disruption in the quiet understanding that holds the cell together. But even then there is hope. Cells can restore their dialogue. They have pathways for repair, signals for renewal, mechanisms to rebuild the bridges between organelles. It takes time, it takes energy, but it is possible. Life, even at this microscopic scale, desires wholeness. Tonight, as you breathe, your cells speak to themselves, not in syllables, but in pulses, in flows, in tiny shared molecules. A vesicle leaves the ER and is greeted by the Golgi. A calcium ion slips from mitochondria to ER in a single whisper of trust. A misfolded protein is carried to the lysosome for gentle dissolution. And through it all, the cell remains whole, not because it is perfect, but because its parts are listening. You too are made of such conversations, not only the ones you speak aloud, but the ones that shape you silently, the ones your cells carry out in your name again and again without noise. You are alive not just because of energy, but because of understanding. And in every cell, every night, that understanding continues, unseen, unspoken, but profoundly real. Let us now drift deeper into the delicate conversations within your cells. If Section 1 introduced the quiet exchanges that maintain balance, then now let us explore the subtler layers, the emotional timbre of this cellular dialogue, because the cell doesn't merely operate like a machine. It listens like a friend, it responds like a healer, it adapts like a memory, and in every corner of your body, that sensitivity unfolds in gentle rhythms. Begin with the nucleus again, the keeper of your genetic story. Though nestled in its shell of double membranes, the nucleus is anything but isolated. It constantly senses what the cell feels, and in response, it releases new instructions. When the environment is warm and safe, the nucleus sends out blueprints for growth. When there is stress, heat, toxins, a virus, the nucleus doesn't panic. It sends out messages that adjust the cell's behavior. It may instruct the mitochondria to conserve energy. It may ask the ER to produce heat shock proteins to protect what's already made. These are not commands shouted across a distance. These are soft messages carried on strands of RNA, messengers of adaptation. The ER, in turn, becomes a translator. It does not simply receive instructions, it understands context. For every message that arrives, it considers how to fold the protein, how to shield it, whether it should even be made at all. It monitors the load carefully. If too many unfolded proteins accumulate, the ER raises a soft alarm, a signal called the unfolded protein response. It sends messages not only to the nucleus, but to the Golgi, the mitochondria, and even the cytoskeleton. It says, there is strain here, please adjust, and in most cases, the cell responds in unison. Some processes slow down, others accelerate repair. It is not panic, it is patience. This collaborative tone continues through the cytoskeleton. These fibers are not fixed like wires. They are more like threads of mood, constantly rewoven to suit the cell's internal emotion. When stress signals rise, the cytoskeleton rearranges. It pulls the nucleus closer to safety. It widens the space near the Golgi so more vesicles can move. It shifts mitochondria toward energy-hungry regions. This isn't rigidity, it's empathy in structure. The cell, feeling its own state, adapts its shape accordingly. Even more remarkable is how mitochondria respond to these emotional cues. These organelles, shaped like winding rivers, can fuse together or break apart depending on the message received. When energy is abundant and the world is calm, they fuse, long and interconnected, efficient in their breath. But when stress comes, they fragment, becoming smaller, more agile, ready to respond. This is not damage, it is readiness. Mitochondria send out signals called ROS, reactive oxygen species, not just as warnings but as messengers of urgency. They are not dangerous in themselves. They are part of the language, and nearby organelles hear them, shift their work, protect the cell. The Golgi, too, hears this emotional tone. When stress hormones rise or viral RNA is detected, the Golgi may restack itself. Its folds become more curved, more flexible. It releases different vesicles, some to deliver proteins quickly, others to slow the system down. It listens for cytokine requests from the immune system and adjusts output accordingly. In neurons, it may form Golgi outposts near synapses, extending its reach like a hand held out in support. The Golgi does not react out of fear. It moves with care, deciding what should be sent and when. One of the most beautiful examples of organelle communication comes during the process of autophagy, the cell's gentle recycling. When the cell senses that it has accumulated too many old proteins or damaged mitochondria, it begins a soft cleanup. A membrane, often sprouting from the ER, wraps around the debris. This wrapping becomes an autophagosome, a kind of bubble. Then the bubble moves, carried by the cytoskeleton, toward the lysosome. The two merge. The lysosome opens and its enzymes begin their quiet work. What was old becomes raw material again. Amino acids are reclaimed. Lipids are stored. The cell renews itself, not through violence but through understanding. Every organelle involved knows what's happening, and they allow it, support it, complete it. This entire system is a reflection of balance, not just mechanical but emotional. A body of communication based on trust, responsiveness, and grace. You are not alive because one organelle controls the others. You are alive because they listen to each other, because they change when one is in need, because they recognize patterns even before they turn into damage. Even in the earliest signs of cellular stress, the network begins to adjust, and in many cases, you never even feel it. Because the system already corrected itself. There are times, however, when the signals become confused. In autoimmune diseases, for instance, the communication between organelles and the cell surface can be misread. The nucleus may send out normal proteins, but the Golgi tags them slightly differently. The immune system, reading these tiny changes, interprets them as danger, and suddenly the body attacks its own cells, not out of malice, out of miscommunication. The dialogue, so subtle, went slightly off course. In some forms of cancer, the nucleus becomes too loud. It sends out too many growth messages. The ER becomes overwhelmed. The mitochondria provide more energy than is needed. The Golgi packages everything and sends it outward. The lysosomes slow down their cleaning. The entire conversation becomes rushed, distorted. The language of health is replaced by urgency, expansion, noise, and the balance, once so quiet and careful, is lost. Not because the organelles failed, but because their rhythm was overtaken. Still the cell tries. Cells have built-in ways to return to balance. They can pause the cycle. They can reduce protein synthesis. They can trigger apoptosis, a gentle form of self-ending to protect the tissue around them. Even in death, the cell communicates. It wraps its parts, signals its neighbors, and dissolves without causing harm. This is not failure. It is a final act of grace, a way of preserving the larger community. And what can we learn from this? That the health of a system is not in its perfection, but in its communication. That harmony is not the absence of challenge, but the presence of response. Your cells know this. They have always known, and every second of your life they are living it. So tonight, as your thoughts soften and the outside world dims, remember this. There is a world within you where everything peaks, not with sound but with presence, not with urgency but with attention. Your organelles do not seek control, they seek understanding, and from that your life unfolds. Even now, a mitochondrion senses your slowed breath and adjusts its energy. The eases its folding pace. The Golgi reduces its shipments. The lysosomes hum softly in the background. Your cells listen to your rest, and they respond. Let us now complete the quiet circle we've been tracing. We've wandered gently through the cellular corridors where organelles speak not with voices, but with the soft movement of molecules, with touch, with timing, and with purpose. And as we come to the final part of this story, we reflect on a simple truth: communication is life. The cell is not alive because its parts exist. It is alive because those parts know how to listen, to respond, to adapt, and above all, to care for one another. Consider how these relationships hold up not just in comfort, but under pressure. During infections, when viruses or bacteria enter the body, the cell enters a state of quiet defense. Receptors on the membrane detect the intrusion and whisper warnings inward. That signal moves swiftly to the nucleus, where genes of defense are turned on. The prepares proteins that will help the immune system. The Golgi wraps them with care, tagging them for release. The vesicles carry them out like letters of warning, addressed to neighboring cells, to immune responders. Mitochondria shift their output, offering energy to fuel the response. Lysosomes stand ready to break down invaders. All of this happens not in panic, but in deeply coordinated calm. It is a dance, not a storm. 1,000 soft decisions made in shared understanding. Even the cell's outermost barrier, the plasma membrane, participates with intention. It becomes more selective, tightening its borders. It draws in fragments of foreign matter for inspection. It uses its embedded proteins to signal distress to other cells nearby. And all the while, the cytoskeleton shifts shape to support these efforts, repositioning organelles so that messengers move more quickly and vulnerable areas are shielded. This isn't chaos, it's care. And when the threat passes, another conversation begins. The cell doesn't simply return to its previous state, it rebuilds. The nucleus shifts its focus toward recovery. The slows production to give the cell a moment of rest. Mitochondria rejoin, fusing their fragmented bodies into long, elegant threads once more. The Golgi reorganizes its stacks, resuming the gentle sorting of new instructions. Lysosomes process debris left behind. The cell is not simply surviving, it is healing. And healing, at every level, begins with communication. We see this again in the early stages of life. As embryos develop, cells must decide what they will become: a nerve cell, a muscle fiber, a skin cell. Each choice is shaped by signals from neighboring cells. But within each individual cell, organelles talk to one another to make that choice real. The nucleus may send out a specific gene message, but without the folding that protein, without the Golgi modifying it, without the mitochondria providing the needed energy, that message stays silent. Differentiation is not a solo decision, it is a collaborative act, a shared agreement between inner voices that whisper, "This is who we will become." And in adult bodies, this collaboration continues endlessly. In your heart, where muscle cells beat in constant rhythm, the mitochondria are especially rich, always responding to the energy demand. The ensures calcium signals flow smoothly, guiding contractions. The Golgi ships out membrane proteins that help cells adhere tightly to one another. In your liver, detoxification depends on coordinated action between peroxisomes, and mitochondria, processing, neutralizing, and recycling. In your brain, synapses function only when the Golgi, and lysosomes work in harmony to produce and regulate neurotransmitters, prune receptors, and clear out excess. Everywhere you look, beneath every function, there is this gentle system of mutual reliance. Even the smallest mistakes are felt deeply across the network. A protein misfolded by the may cause the Golgi to halt its packaging. Mitochondria might sense rising stress and fragment in response. If too many faulty proteins accumulate, the cell might pause division or initiate a slow cleanup through autophagy. And if the problem cannot be solved, the organelles together agree it is time to end. Apoptosis begins, not in anger, not in failure, but in peace. The mitochondria release signals that tell the cell, it is time. The nucleus responds by wrapping up its DNA. The stops producing. The Golgi shuts down its sorting. Lysosomes prepare to dissolve the cell from within, and the plasma membrane blebs softly, signaling to nearby cells to come and carry the remains away. The body does not scream. It honors the cell with violence. This quiet death protects the tissue. It ensures that one cell's struggle doesn't become many, and even in this ending, the organelles work in unison. A final conversation, a final kindness, a final truth that no part of life happens in isolation, not even its end. So as you lie still, perhaps ready for sleep, imagine the countless moments unfolding within you now. Picture your cells not as factories but as families, each organelle playing its part, listening with care, speaking with purpose. Their voices are not loud, they are not fast, but they are constant, they are faithful, they are alive with meaning. The Golgi folds a vesicle and sends it to the edge of the cell. The ER senses a shift and pauses its work. A mitochondrion moves closer to the energy it must provide. A lysosome completes its recycling and waits quietly for the next call. Nothing is rushed, everything flows. This is the language of life, not spoken in words, but carried in waves of presence, of adjustment, of trust. And perhaps that's the deeper message. That inside you, beneath every heartbeat, every breath, every thought, is a world that works not through control, but through conversation, through mutual recognition, through quiet love. Your body is not a machine. It is a whispering forest of cells, and each one is lit by dialogue. Tonight they are still speaking, and as you rest, you are not alone. You are carried in their conversation, held in their coordination, protected by their care. Let that comfort you, let that truth soften your edges. Because inside you, even in sleep, every part of you is listening.